Welcome everybody, my name's David Wood. We are here for a London Futurist event courtesy. Thanks very much to UCL who provided this facility tonight. London Futurist, as most of you know, is a meetup where we try and think pretty seriously about some of the possible scenarios for radical change over the next few decades. We're thinking that there might be some significant changes ahead, and that it's better to anticipate them before they happen, so that if necessary, we might collectively act to get things changed. So we're looking at what technology might do. We're also looking at how people might react to technology, how politics might react. We're looking at what's credible. We're also looking at what's desirable, because sometimes our first reactions will mislead us, because after all, the kind of future that lies ahead may be quite different from the landscape and environment in which we historically grew up in evolutionary terms, in which formed our instincts. So London Futurists is about looking at the future scenarios, getting beyond that future shock in which we're sort of dazzled by the bright headlights, and being able to think more clearly. And one of the scenarios which probably most needs clear thinking is the subject of tonight's talk, geoengineering. The possibility that by conscious use of technology, we might significantly alter the climate on parts of the Earth as a deliberate measure against some of the accidental impacts on climate which have taken place as a result of human activities with carbon, greenhouse gas emissions over the last century, and particularly in the last few decades. So should we get involved in that or not? What kind of experimental basis can we use to take our decisions? The Royal Society, here based in London, has been one of the scientific bodies that has looked more seriously at this question. And we're very fortunate that the person who's speaking to us tonight, Dr Jack Stilgoe of UCL, has, amongst other things, been closely tracking some of the discussions in the Royal Society from his standpoint as somebody interested in the policy of science and in the practice of science. So he's going to use geoengineering as a way of thinking about how can we know the limits of responsible science, and what attitude should we take about these potential large-scale impacts which could come through us exercising science. Dr. Stilgoe has also worked with think tanks such as Demos, and he is an active lecturer here. So I'd like you to welcome him, and he's going to talk us through geoengineering, experimental Earth, and lots more.
Thank you very much. So thank you all. Thank you for the invitation. It's a pleasure to be able to talk to a group that's already engaged with these sorts of discussions. I mean, I guess my starting point is similar to one that you will share in this room, in that I think that technologies are transformative and they're powerful, and that we need to anticipate their possibilities. But I try in all my work to avoid any sense that the future is predetermined. So my instinct when I'm thinking about emerging technologies is to consider the possibility for democratization, to consider the future as a shared space that is not yet determined, and to find opportunities to steer innovation in ways that we might regard as the public interest. Geoengineering is a particularly interesting example, I think, because, and I'll come on to talk about this a bit later, we are already talking about geoengineering as though it were a thing, as though it were a technology. And it's easy to forget that it doesn't exist yet. It's easy to forget that mostly it's a set of ideas, and therefore the question of should we or shouldn't we is a very open one. And the interesting thing I've found in my work with scientists is that some of the most prominent people asking that question are the scientists themselves. So this is not a simple situation in which scientists think something, citizens think something else, and we worry about the disconnect between them. This is a situation in which scientists themselves are expressing huge ambivalence. To give you a sense of where I'm coming from, so earlier this year I published a big book that's grotesquely expensive, which I can only apologise, but what I did as a deal with the publisher was get them to put the first chapter online, so you can go have a look at that. I knew that I would put the first chapter online, so I tried to put all the meaningful stuff in the first chapter, because I know that nobody buys, let alone reads, academic books. There are also some shorter versions which are open access, so that one is in the Journal of Science and Engineering Ethics. This one was in The Guardian a few months ago, and I've got the shortest possible version as well for anybody with concentration troubles. So this is a good time to talk about geoengineering because, as we've already discussed, we've just had the one of these odd meetings where the UN Framework Convention on Climate Change organises a conference of the parties in order to discuss what we're going to do about climate change. And these tend to result in deals that everybody says are wonderfully successful, and then immediately afterwards the truth of them starts to leak out. And for people that weren't there and aren't involved in climate policy, it's extremely hard to know, well, is this the saviour that it's being presented as, or is it a failure, or is it somewhere in between? And are we able to take charge of an issue as complicated as climate change? The evidence, all I will say, from the last 20 years or so of having had climate change as a prominent science policy issue, a prominent policy issue, is that we have demonstrated collectively our ineptitude at dealing with it. So carbon dioxide emissions, greenhouse gas emissions have kept on going up. The only thing over the last 20 years that has abated them at all has been a global recession, which only a few people regard as a sensible policy for dealing with climate change. And this is part of the background to the contemporary discussion of geoengineering, is the seeming collective failure to tackle climate change. And one of the reasons why this set of proposals have come up the political agenda. But my story starts rather longer ago than last week. It starts with a volcanic eruption that took place almost exactly 200 years ago. So this was, I'm going to tell you that this is the eruption of Mount Tambora. It's actually not, it's actually another volcano in Indonesia, but you know, what's volcanoes in Indonesia between friends? Mount Tambora was the largest volcanic eruption of modern times. It was so large and so disastrous at the time that it killed thousands in its immediate vicinity, but its impact on the world was far greater. What happened, so it erupted in April 1815, just over 200 years ago. And the cloud of sulfates that was emitted from the massive volcanic eruption entered the stratosphere and started spreading around the world, which had various effects, various interesting effects, including that in Europe, painters at the time, so these people like Turner and Constable, started trying to replicate the vivid sunsets that they were seeing. And historians of art have gone back over these, over the paintings and worked out that there was an unusual quantity of red paint used during this, the 2 years immediately after the eruption of Tambora, because of this global haze around the world. 1816, the year afterwards, was known as the year without a summer. It led to famines, food riots, various other global instabilities. And on the shores of Lake Geneva, 4 friends were gathering for their summer holiday that summer, and the weather was so bad that they had to stay inside. One of them dared the others to write ghost stories, which makes the most famous cultural offshoot of Mount Tambora, not Turner and Constable's paintings, but of course Frankenstein. Come on. So Frankenstein, interesting for my purposes, I'm talking about responsible science and innovation. Frankenstein clearly remains the ultimate parable of irresponsible innovation. It is a precautionary tale, if you like, about what happens with a lack of care of science and its creations. The story that Frankenstein has become, suffice to say, is nothing like the story that Mary Shelley originally wrote at the time. The Hollywood version, this is the classic. This is the classic retelling in which this guy doesn't figure in the book. None of this is described in the book. The mad scientist doesn't figure in the book, and the evil monster doesn't figure in the book. Interestingly, the monster in the book, those of you that have read the book will remember, is of course not born bad, but is made bad through a lack of responsibility. Bad parenting. Right? Frankenstein is a story of bad parenting. That story and its subsequent mauling by Hollywood inspired a guy called Langdon Winner, who some of you may have come across, a brilliant philosopher of technology from the States, to write a chapter on the trouble with Frankenstein, in which he elucidated his own theory of a politics of technology, which I just want to touch upon now, where he introduced a few ideas that some of you will recognise. So ideas, he called it technological somnambulism, right, which I guess inspires the thinking behind a lot of this group. The idea that technologies just happen to us, we allow them to happen to us. We don't think deliberately about their implications or their directions, and so in that sense we're sleepwalking into the future. We talk in terms of the regulation of technology or the legislation of technology, but Langdon Winner's point was that technology itself was a form of legislation. It shapes our lives, it controls our lives, it locks us into various patterns and routines, and we become dependent on, for example, the internal combustion engine driven car, and we find it rather difficult to extricate ourselves from it. And so Langdon Winner's question was, what would a more democratic politics of technology look like? He came up with various examples and talked about their politics. So the examples of nuclear power, for example. He talked about the set of bridges that cross the roads to Long Island from New York, which he labelled racist bridges because they were designed specifically to stop buses from getting underneath and stopping poor black communities from reaching the beaches. But if we're looking for a more mundane political technology, we might look to, for example, this bench. It took me, given that I'm a studier and lecturer in the sociology of technology, I should have noticed this earlier, but it took me years to work out what this bench was really for. Right? Because there are various ways of reading that bench and say, well, that's so that one particularly fat person can't take up all of it or whatever, but it is, of course, an anti-sleeping bench. It is a discriminatory technology in which it's specifically designed to stop homeless people from using that public space. Now, Langdon Winner's theory of technology takes us to some interesting criteria that I ask my students to think through technologies with. So I ask them to look at their smartphones and say, is this a good technology? And you can think through in terms of Langdon Winner's criteria whether technologies fit or, and if they don't fit these criteria, what we might do about them, how we might worry about them. Now, it becomes more problematic when that technology doesn't exist. So if technology exists as a set of proposals, how then should we think about technology? And here is where I like to think in terms of experiments. So I like to think about not just experiments that are happening in places like UCL and universities up and down the country, but to think about technology itself as a social experiment. And the reason I got involved with geoengineering was because of one particular experiment which emanated from the very same meeting in Cornwall. So here is an experiment, and there's two ways of describing this experiment, both of which are true, but which lead to rather different discussions. So one way of describing this experiment, it involves a World War II era blimp, a very old technology to which a hose would be attached, another old technology, a water pump that you would buy at B&Q would pump up about a bathtub full of water into the sky and squirt it out. That's it. Everybody agrees that that water would pose no direct risk to the environment. And everybody agrees that even though it would be a risky experiment, there's a chance that the balloon would burst, that the hose would break, etc., etc. Those are the sorts of risks that engineers are quite good at understanding and dealing with. That's one way of looking at the experiment, and my guess is that phrased in that way, none of us here would have a problem with it, right? Because we run odder experiments than that every day at, in universities and other places. Another way of looking at this experiment is that it's the first field trial of a geoengineering technology anywhere in Britain, if not Europe, if not the world. Right, this is part of a project called SPICE, Stratospheric Particle Injection for Climate Engineering. Even just, I mean, so the experiment, the schematic of the experiment is still extremely modest, right? You'll see that it's only 1 kilometre high, which isn't that high. The hose isn't very long, tiny amount of water, most of which will evaporate before it hits the ground. And yet this experiment became a focus for substantial debate about 4 years ago, this was. And among those most involved in the debate, most unsure actually, were the scientists who had proposed running it. This was a collaboration between some climate scientists, some engineers, and suffice it to say that within the team there was a difference of opinion about why this experiment should take place, if at all. If you look at the website for the SPICE project, you see a balloon that isn't 1 kilometre high, but is 20 kilometres high, and suffice it to say that with current technologies this is impossible. There is no way of building a balloon 20 kilometres in the sky, attaching it to a hose and squirting out what wouldn't be water, but maybe sulfates, maybe some other form of reflective particle. But should one want to ask about the SPICE project, one would go to the website and see that. And for some people that became a clear statement of intent. That was problematic, and we will see why. So for some people, the balloon then, even though it was a modest experiment, not a risky experiment, not even an unethical experiment according to the rules of ethics that we enforce through our universities. But there was some sense in which this balloon was, and this was a quote from one of my interviews, it was the imaginary made real. For the first time, this was a set of imaginary proposals that somebody had said, okay, well, let's see if that would work. And therefore it took a debate to the next level. A group of small but vocal NGOs campaigned against the SPICE experiment with the use of rather laboured puns. They had previously been behind a campaign against geoengineering that they called Hands Off Mother Earth. And the language here is interesting. Our home is not a laboratory, right? This is the language of experimentation in which citizens are presenting themselves as unfortunate and unwilling guinea pigs. And it's a language of experimentation that is familiar from past debates about GM crops, genetically modified crops. This is Greenpeace's campaign in Germany against genetically modified crops that say genetic experiments turn men into lab rats. I don't know if anybody speaks better German than me, that's close enough. And this is a film that was made about GM crops and nuclear power in French. Are we all guinea pigs, it's asking. Right, this is a classic language of protest against emerging technologies, that we are being experimented upon, and therefore the ethics of our involvement in it should be experimental ethics. Now, I should probably explain at some point what geoengineering is, which I'm going to do in the simplest possible way.
How do we get rid of the greenhouse gases?
Fortunately, our handsomest politicians came up with a cheap, last-minute way to combat global warming. Ever since 2063, we simply drop a giant ice cube into the ocean every now and then.
Just like Daddy puts in his drink every morning, and then he gets mad.
Of course, since the greenhouse gases are still building up, it takes more and more ice each time. Thus, solving the problem once and for all. Once and for all!
So the point, obviously, is not to say that that is a geoengineering proposal that people are taking seriously, but the critique, as with all good satire, is absolutely spot on, and it's a critique not of a particular technology that we can work out the costs and benefits of. It's a critique of the idea of techno-fixing the climate. And the idea of techno-fixing the climate that suggests that rather than tackling the problem, what we do is we tackle its symptoms, and in doing so postpone or exacerbate the underlying problem. And that's at the heart of many people's concerns with the ideas being suggested for geoengineering. So this is one summary of what's sort of on the table. And they can be, geoengineering proposals can be split into two groups normally, although that's only one way to cut up the issues. On the top right, we have what's called solar radiation management. So if we could cut the amount of sunlight reaching the Earth, then we would be able to cool it, reaching the surface of the Earth. On the bottom left, we have carbon dioxide removal, which suggests that if we could clearly suck out the greenhouse gases that are already in the atmosphere, then we could avoid the worst problems of climate change that way. And what I'll do is keep most of my comments relating to option 1 there, which are reflective aerosols, because that's the option under consideration by the SPICE project. So the reason why that balloon was floating 20 kilometers in the sky, the imaginary balloon was floating 20 kilometers in the sky and spraying out sulfates, was, if you like, just to mimic the effect of Mount Tambora, to do Tambora's job, but in a controlled way, to cool the climate in that way by creating a stratospheric haze. But other methods are available, or let's not forget, they're not available. Other methods are imagined. Okay, so let me just return to then the idea of technological fixes. So technological fixes, as the social science literature would have them, have become it's become a rather pejorative phrase, the technological fix. It's seen as you're not really fixing anything, right? If it were a fix, it would suggest that the problem was a simple one, and the problems are rarely simple ones. Nevertheless, we can differentiate between good fixes, where they tend to work, bad fixes, where they tend to screw things up, and ugly fixes, which are the vast bulk of technologies that do something good but exacerbate problems, postpone problems, make some things worse, create new inequities, or generally sort of intervene in ugly ways. But the idea of the technological fix as originally proposed by Alvin Weinberg was about the elegance of technologies being able to cut through Gordian knots. It was about finding wicked problems and saying, rather than trying to untangle their social threads, can we find ways just to cut through them? So if we look for examples of good technological fixes, you can probably think of your own, but We can imagine something like the smallpox vaccine. A smallpox is a complicated illness, but a vaccine is an elegant way to cut through that problem, chop it off, and we would probably all agree that having smallpox eradicated was a good thing. We can look at bad technological fixes, and again, we'll probably all have our favourite options, but we could look at something like Reagan's Star Wars program as one example of a technological fix to something that was itself seen as a technological fix, namely the hydrogen bomb. And we could probably laugh at that now and say, well, it's probably a good thing that that wasn't built. But most technological fixes would be ugly ones in that they tend to create problems as well as sort things out. And that's typically the way that we have proceeded, is by introducing ugly technological fixes, trying to fix the bits of the fix that we don't like, and proceeding in those sorts of terms. So one can look at, for example, developments in agriculture as a beneficial technology in that people were fed that otherwise would have starved, but in so doing increased a dependence upon fertilizer, increased the emission of greenhouse gases. Many of them were unsustainable and so needed subsequent fixing, benefited some people more than others, etc., etc. And you can start to see that technologies are ugly. For geoengineering in particular, let me reiterate that some of the people leading the critique against geoengineering have been the scientists themselves. This was a very influential paper that came out, written by Alan Robock, which he called elegantly 20 Reasons Why Geoengineering May Be a Bad Idea, in which he elucidates some of these and has gone on to list more. But among the reasons why he thinks geoengineering looks bad, especially geoengineering of the flavour that I've described there, would include the effects that it would seem to have on regional climate. So we know from large volcanoes that when they erupt, yes, they do cool the planet, but also they do all sorts of other things, some of which are nasty things to the planet. They disrupt weather systems, they disrupt rainfall. We knew that with Tambora, although it involved piecing through historical records in order to find that out. Smaller volcanoes that have erupted since have been able to be captured by satellites and described by climate models. We don't know precisely what such a system would do, but we know that it would do something, and that something might give us cause for concern. So again, without saying there is an unmitigated problem here, it's one reason why we might want to worry. Second reason, if we're controlling sunlight, is clearly the oceans would continue to acidify. Another effect of climate change that would be left untackled by this symptomatic treatment of one of the effects. There's a very interesting set of arguments about whether this would be reversible. And we can run this in various ways. Alan Robock had this as one of his reasons. There's no going back. We can look at, as I've described, technologies like the motor car and say there is a technology that once we have become dependent upon it becomes very hard to reverse. Not impossible. It looks easier now than it has done for decades. There's a set of interesting technical arguments within the geoengineering research community about something that's called termination shock, that suggests if you did become dependent upon this global sunshade, and if you ran a scenario in which you were able to cool the planet, so that's what's happening here, the temperature is rising because of climate change, you've introduced your sunshade here, started cooling the planet, and if for some reason the sunshade stopped working, or if we decided that we were no longer interested in using it, or if terrorists attacked the facilities, or whatever reason, or something went wrong, because things always go wrong with technology, you would get a very rapid warming that would be extremely hard to adapt to. Right? It's hard enough to adapt to the gradual warming of the planet under conditions of climate change. It would be harder still to adapt when the warming was happening more rapidly.
Excuse me? Could I ask something? The variability on the upper side seems a little bit exaggerated. Is that, could you elaborate a little bit on what kind of scenarios these are?
When you say exaggerated, do you mean what that is higher?
Yeah, and it seems to be too high, right? I mean, even according to what's the
What I mean, I'm afraid my understanding of these graphs is as complicated as it needs to be. But my sense from these is that what would happen is this is all of the amount of warming. These are different levels of climate sensitivity.
Yeah.
This is all the amount of warming that you would have got in a non-geoengineered world.
I mean, I understand. I mean, you have the upper graph, which shows the non-geoengineering scenario, right? And then you have different sub-scenarios, right? Which then probably different models, right? Subsets of models or something, right? And then you have the lower one, which shows then, okay, you have the intervention in 2020, right? But yeah, just the variability seems to be too high.
The thing is, I think there's different levels of CO2 in the atmosphere, and I know whether the one at the bottom is you assume you've done nothing with the CO2 level.
Yes, indeed. So that's entirely sunlight.
Because I mean, the idea with geoengineering is you would instigate that as a temporary measure and then reduce the CO2.
Well, one idea.
That's one idea. I mean, you could not worry
the numbers of scenarios that you might run. Andrew, can you help us out?
A quick point. That research was done in 2009, and researchers published that the blend of this year has shown that there's a significant uptake of CO2 into the oceans from solar radiation management. So the resurrection shock would never be as bad as the original warming.
Okay.
It might be faster than the original warming, which is bad in itself. So rate of warming is a really big problem, but the absolute temperature change is never as bad as the original.
Thank you. Okay. I mean, so the reason why I put this up is as one of the dynamics of irreversibility that would mean that once you became dependent upon this technology, weaning yourself off it would be extremely hard for technical, social, political reasons. We know from technologies past that we do become locked into technologies in all sorts of ways, right? Does anybody know what this is?
It's something wrong.
There's something wrong. Yes, this is the Dvorak keyboard, which is the classic study of technological lock-in, because typing fans. I don't know if we have any.
Doesn't work.
They would say that the QWERTY keyboard is a terrible, terrible invention. Historians of technology worry about, well, why is it? How do we end up with it? That's not the point I'm trying to make. The point I'm trying to make is that we have ended up with a suboptimal technology. Better alternatives exist. Why don't we use them? Well, it's clear why we don't use them. It becomes very hard to change direction. We are locked into this particular technology. And this is a mundane technology, right? Not one on which the world is hugely dependent, not one on which there are hugely high stakes involved. So Alan Robock is interested in these political dynamics as well. He asked the question, which is entirely legitimate. So we are presuming that we have a global technology here. Who would control such a technology? How would we agree on what the ideal temperature was? Would we expect a farmer in Mali to agree with a farmer in Siberia about where they would like the thermostat to be set? Well, probably not, and probably neither of them would have the slightest bit say in it anyway. And then finally, other things, because technologies always bring unexpected, unintended consequences. And to pretend that we can predict them, to pretend that we can know the consequences of a technology, is an act of extraordinary hubris. This would be necessarily some form of experimental engagement with the planet, and it would be an experiment in society as well. One of the major concerns with all of this is that politically geoengineering as a proposed techno-fix, even if it doesn't exist, would seem to present a get-out-of-jail-free card to people like the negotiators in Paris. Should they take this seriously as an option? Should it be seen as a relatively cheap and easy and effective and relatively less risky option? It might be seen as seductive, in which case the incentives to mitigate carbon dioxide emissions might drop. As far as I know, it didn't figure prominently in the Paris negotiations, but it has figured in the IPCC's negotiations, so I have been rather critical of the inclusion of geoengineering in the Working Group 1 report of the IPCC Summary for Policymakers that added geoengineering as a sort of coda paragraph to the end of the report, which seemed like a rather odd piece of politics. A lot of people on the IPCC would say our job isn't to do the politics, our job is just to represent what the science says. But it seems odd that it turned up in Working Group 1 of the IPCC, which is about the physical science basis for climate change, rather than about something to do with technological options. And this takes me to my next point, which is about how we tend to treat geoengineering. We researchers on it tend to treat geoengineering as a thing in the world to be studied, rather than a particular direction, a technological direction, in which we might think about should we or shouldn't we, what are our responsibilities. One of the most prominent geoengineering researchers, David Keith, opens his book, A Case for Climate Engineering, by saying it is possible to cool the planet. It is cheap and technically easy. Right? It isn't. I mean, that's flat wrong. What he's saying is that, in effect, I mean, this is classic presentation of technological determinism, is that if you run some scenarios, it becomes possible to imagine a future in which this becomes cheap and easy at some point soon, but those are only particular scenarios, those are by no means inevitable. And yet we tend to naturalise these things. We say, given that it is cheap and easy to do geoengineering, should we or shouldn't we? How should we study it? How should we be worried about it? The Royal Society's own report on geoengineering looked at the various options on the table, and of those options, stratospheric aerosols, the one that I've been focusing on here, would appear to do best both in terms of affordability and effectiveness. I would say the error bars on that affordability blob should be absolutely vast, given what we know about the affordability of something like nuclear power, originally presented, let's not forget, as too cheap to meter. We simply don't know. So the uncertainties sitting behind that diagram that look like a fairly objective assessment of technologies in the world are actually vast. But the point is we don't know, and so we should start finding out, the researchers would say. And geoengineering research is a very recent phenomenon and a very small world. So this is the growth in publications from some scientometrics work that we did, where we just look at papers getting published and who they're citing. The world of geoengineering research, if you map all the authors, looks something like that, where you see a few big players and not very many other groups around them. If you were to compare that to other areas of emerging technology, there would be a much bigger network, and it would be much more spread out. So we shouldn't forget that the network of researchers is a small one. When I show this at geoengineering conferences, everybody immediately tries to find themselves on the map. We can play that game later. But in geoengineering research is also, which is a good thing, it is highly interdisciplinary. So this is not an area in which, you know, it is a group of engineers saying we will proceed regardless of what anybody says. Geoengineering, peculiarly, since it emerged as a topic of serious scientific concern, has been done by highly interdisciplinary groups of science. So this is a map of scientific journals telling you what gets published and what links those particular disciplines have with other disciplines. And what we can do is map particular fields onto that global map of science, and we see how geoengineering looks in a disciplinary mix. And this, I mean, either, you know, there's not a huge amount, as you would expect, in the sort of medical psychology area, but it's a pretty diverse group of people involved in geoengineering. We have a sizable chunk of social scientists. As you would imagine, the bulk of them are in the atmospheric scientists and meteorology. Oddly, and this relates back to my point about studying geoengineering like it's a thing in the world and not a technology, there are very few engineers. So engineering is the missing discipline from geoengineering. So it's studied as though it were a technology to be assessed rather than asking the sorts of engineering questions. And this is one of the reasons why the SPICE project was so disruptive, because it asked engineering questions. Well, how would we actually do this? Which unsettled people. Didn't just unsettle the NGOs, it also unsettled a lot of the other geoengineering researchers around the world who had in their minds a particular order that things should be done in. I have more to say, but I don't really want to say it because I'd rather have a discussion about what we might do about all of this. Let me just finish my story then. This is the world of geoengineering research in which I ended up as a slightly accidental part of it, as a collaborator on the SPICE project. A collaborator in the genuine sense, you know, of sharing an experiment, sharing a laboratory with these scientists. The scientists involved in the SPICE project decided not to run that experiment. It generated more controversy than they were expecting. There was the discovery of a patent on that idea of the 20-kilometre high balloon that made some of them feel rather uneasy. There was a sense among the scientists that we hadn't yet established any social rules or norms for dealing with these things, so therefore it may not be very responsible to proceed. And so the experiment never took place. We are at the stage now where others have proposed experiments to take place that will invite some share of this public discussion again. But I want to just leave, if you like, with a statement about scientific ambivalence, which comes from one of the scientists in the SPICE project. So one of the things that I did a lot of was interview the SPICE scientists themselves. And I think what this quote captures, which is quite nice, is that it's the scientists themselves who are asking these questions, quite often quietly. So they aren't the scientists that are most prominent in the geoengineering debate, but that this scientific ambivalence is a rather good thing. And I think I'll end there. Is that all right, David?
That's fine.
Thank you. That's from Frankenstein, by the way. That's the final piece of Frankenstein.
So you've described the scientists in Norfolk as being careful and responsible. Is there a worry that scientists in other parts of the world might be a bit less responsible and careful, and they might be in more of a hurry to do their experiments?
I mean, there is clearly it's a sort of typical feature of any emerging area that scientific excitement can run ahead of an ability to fully understand the political or ethical concerns. Again, I'm more optimistic about geoengineering research than I am about some other areas. Particularly, and one of the reasons I'm optimistic is because there isn't a huge market push. So if I may just, the other experiment that has attracted a lot of attention was an experiment run by a guy called Russ George, who is a more interesting character. And I think because he is not a university scientist, he is, well, I don't. If I were to describe him, I would maybe libel him. But if you go to his website, he has this mantra: "Save the world and make a little money on the side." And what he was interested in was pumping iron into the ocean to see if he could generate algal blooms that might act as a carbon sink. And one of the reasons he would admit that he was interested in it because it creates the possibility of selling carbon credits. So one of the questions with geoengineering is there a market driver? In the solar radiation management area, I don't see one. And in lots of other areas of emerging technologies, I do, and this is why I'm slightly more worried, I guess, about schemes like this. Now, it turns out that the community's reaction to that experiment was a relatively healthy one, which was to say, that's irresponsible, and it's probably a rubbish experiment anyway.
So that's the discussion of commercial pressures, but might there be political or military pressures in the way that some scientists are told by their governments, you'd better work on the nuclear weapons, or you'd better work? Are there parts of the world in which they say, look, we want to be sure that we've got some controls over this, you're going to work on this regardless of what your conscience says?
Yes, and again, I'd say we would be right to be concerned about those sorts of things. So for all of this stuff that I was talking about that's happening in public, the concern is what's happening that we're not hearing about, where scientists aren't actively seeking responsibility, but they are trying to get away with whatever they can get away with. And that's the concern. But I don't share the opinion of many social scientists in the area of geoengineering that the incentives to do this would be so great that we should start running scenarios on sort of Bond villain types who are going out and generating these technologies by themselves and testing them in some underground lab. Because actually the research that has been done suggests it's far harder to do that than it at first appears.
Questions from the audience?
On that one, is there any regulation or monitoring activity right now? Is there any body whose job it is to check on who's doing what?
Well, one of the interesting things, I don't want to put Chris on the spot here, but one of the interesting things generated by a concern about exactly that sort of experiment has been an unusual level of global agreement that sort of experiment should be banned unless it is done for what are called legitimate scientific purposes. Right? So there has been a shared sense that we don't like that sort of stuff. Now, in terms of the regulation of a solar radiation management experiment, as I said with SPICE, I don't think it's the sort of thing where we should be talking necessarily in terms of regulation, because that satisfies all of the regulations, right? It's gone through all the risk assessments, it went through 2 university ethics committees. It's a question really of, well, where should science be heading? Which is a rather more complicated question to get our heads around. Clearly regulations will need to be constructed at some point if people start taking particular things seriously and there are things to be regulated, but we're sort of quite a long way before that.
If we put sun shields in space, I don't know if this is a stupid question or not, but I ask everything. Is the reduction, say it was big enough and we really did reduce temperature, is the reduction equal around the globe, or can you just sort of pick and choose which countries you want to be warmer or not?
Well,
How would it work?
So it's a very interesting question. So I mean, I'm the wrong person to ask about, because you'd have to ask somebody that runs the models on particular technology. But there is a question here about a technology that claims to have a global impact. And most geoengineering is talked about in those terms, in terms of this being a technology for climate change, not for weather modification. Because, let's not forget, attempts at weather modification have been tried, have been banned in most cases because of a fear that states might use them against one another. And so that sort of targeted sense, and we do actually have regulations. We've got the environmental modification regulations from the United Nations preventing those sorts of things, because you could imagine obviously disagreements if those tools were used as weapons of war. No, I think the interesting thing about geoengineering is that it's talked about as an all or nothing deal.
Is
right?
it possible, not that I've got plans to be a supervillain, but is it possible to target temperatures in certain countries?
I think if you were a supervillain, you would come up with better ways to target. I think you could probably put a mirror in space to reduce sunlight, and then another mirror to shine a massive laser on it.
Evan, you want to come
I
in?
was very involved in the spice thing at the
Indeed,
from the
yeah.
onset. In fact, I think my talking to the head of EPSRC some 2 years previous had actually generated that money, which eventually was given to the spice program.
We should
And
talk, yeah.
they didn't look at mine because it was too way out. But mine was much cleverer than the spice program, which I'll tell you about. But the and when I left the meeting about half day out, I gave my list, my preferred list, what should be done, and I put the spice at the top. But I said it'll never work, close brackets, because of these problems. My idea was to actually have geoengineering over the polar regions, because I think that if you can keep those intact, there's a lot more prospect of controlling the climate. But the models to model all this are a million miles off yet. We don't know, we can't tell if you can localize geoengineering yet and what impact it will have on that. We can't model the climate. Don't believe a lot of the stuff you read in the papers. We're a million miles off understanding even how the modest increases into carbon dioxide are impacting the temperature. A million miles off. And so, but the idea of putting them over the polar region I thought was a very good one, and mine were completely safe, completely reversible, completely okay, and but they regard it as too way out to work, but I still don't know. It'd be quite expensive.
What were you going to do? Were you going
It was nano silicon mirrors, which didn't require, which were going to be completely controlled with solar power.
in the stratosphere or above? Or?
Above. They have to be really out of the high above, so that you don't get too much wind and all that stuff affecting them. And there were great sheets of these things, and you could easily control, I think, the sunlight getting directly to the polar regions. I think, and no one could give them the answer when we're there, that would make an enormous difference to actually controlling the planet. But they don't know. The models are not sufficiently developed to do this. I had a long conversation with David Keith about all this stuff, and we're a million miles off understanding what we would do. So it's quite risky. What you have to do is be able to reverse it. Mine were going to fly off to the moon and crash into the moon was my way of getting them out of the way, which you could do with the technology that I sort of come up with. But I don't know. You know, I think it's a long way off us worrying about this. But they and I also asked the climate scientists at that meeting, when can you tell me to switch these things on? If we have that technology proven, when would you say launch? And of course they don't.
Why do you think it would be the climate scientists saying that?
Well, it would be politicians ultimately, but normally advised by the climate scientists, because they say we've gone through a tipping point, for example. If the methane started coming out of the Russia, for example, is that going to be a massive problem? No one knows. So if it did happen, and suddenly in 2070 the temperatures started really ramping up, they might say, yeah, let's do it. But that's got to happen first.
Question here?
Yeah, I really enjoyed the presentation. Thank you so much. I went to a movie recently about actually Antarctica and climate change, and they showed the huge iceberg, like 32 kilometers in length, split off from the continent, and it was circling around the Antarctica for many years, and now it's drifted towards Elephant Island. But my question is, you know, we had a volcanic eruption in Iceland a couple of years ago when all the flights were suspended. And do you know if the temperature has decreased as a result of that, and by how much?
That eruption wasn't nearly big enough. So again, no volcanologist, I'm no volcanologist, but we are talking about the sorts of volcanic eruptions here that are big enough to catapult some particles right up into the stratosphere. Because they need, once the particles get up into the stratosphere, they can start spreading around, otherwise they just fall back down to Earth immediately in the local vicinity, like with the Iceland one. And if I'm right, there have been probably about 4 or 5 over the last century of that sort of
The Mount St Helens eruption in early 1990s, it seems to have had some measurable effect on the climate.
Yeah, half a degree or something for a couple of years.
Maybe.
Quite a big change.
So we didn't end up with a year with that summer.
No.
No, indeed.
Question here?
A bit closer to home. My name is Sophie Church. I'm a forester, actually, in part. And I was in Burkina Faso last week in West Africa with Tree Aid, which I chair. And Tree Aid works with rural businesses and planting trees for environmental management, women's economic viability, and so on. And meanwhile, everything's going on in Paris, so I was sort of catching up with CNN and everyone else in the evening, and then out in the rural areas. One thing that Paris said was that we're now going to stick money in more adaptation and just accepting that some people are just going to have to try and make the best of a second life. Our forestation doesn't really work as a sort of carbon fix, I don't think, globally. But in some circumstances, good forestry can also make people more resilient to the desertification, lack of income, and everything else that's going on with climate change. So I'm just wondering, is it possible to assess some of these technologies not just as an absolute by themselves, but whether they also do other beneficial things? Forestry can be ugly if you're sticking lots of nutrients in and then there's a fire, and like Canadian forests are all going up. But is that part of the thinking at all?
Well, I think it should be. I mean, because I think there's a danger that you look at these things in isolation and that you look at these things as having one purpose. And we know that technologies don't do one thing. They have co-benefits, they have side effects. So any large scheme at this sort of scale, and if you take something like a technology, and to see trees as a technology is already to sort of misrepresent them, but clearly they do act as a carbon sink and do more besides.
They're good as a kit in their core.
And the adaptation question is an interesting one too, because adaptation was similarly a bit taboo, that we didn't, there was such a fixation on mitigation in global climate negotiations that adaptation was seen as let's not talk about that because that seems too fatalistic, or that's giving politicians the same sort of get out of jail free card to just say, we'll deal with a changed climate. But now that adaptation is back in climate discussions, I think we're in a healthier place where we can talk about these alternatives that are messy and not pretend that they're neat fixes to a particular solution. So I'm with you.
I thought I saw forestation on one of your slides.
Yeah.
Afforestation or?
Yeah, it's so growing trees, as a geoengineering method. I mean, where this has been modelled, if you were using that technology as your method, you would have to do so much of it that not only would it, have massive land use implications, but it would probably do all sorts of other undesirable things besides.
Andrea?
The guy before, that's essentially a carbon capture technology.
That's the aim,
Carbon capture has a quite widespread. It can be capturing at source, and it is seen probably if the carbon price goes up to, let's say, 30, 40 euros, as a possible solution. So in this spectrum of possible technologies, so what will the process be of deciding what is acceptable or not?
Well, again, you know, I would see that as a central democratic question. So what the process, the process is open, but also we shouldn't presume that, you know, these are technologies that we are making choices between. This guy is just doing an experiment to see if this is in the slightest bit viable, and turns out that it doesn't really work as well as some people had suggested that it might, and so we don't yet have that discussion of, well, should we or shouldn't we? Right. So I'm saying we are at an experimental phase. How might we decide? Well, you know, there are huge considerations there to do with national politics, international politics, to do with procedural justice, to do with distributed justice.
Is it something that was talked about in Paris, you know?
In terms of geoengineering, again, I don't think geoengineering figured in their discussions certainly prominently at all.
Maybe not with that word, but with sort of let's say the limits of carbon capture.
Yeah, I don't know how much. I mean, I know that it's implicitly already in a lot of IPCC scenarios, the idea that in the future we will be able to remove carbon dioxide from the atmosphere, but we're not quite sure how yet. So that's already written into a number of scenarios, which we may regard as problematic because it may make them more inevitable, but it's there, the suggestion that we will be able to do what are sometimes called negative emissions. But there's not much more for it.
Yeah, so just a point of correction before I ask my question. There are at least 2 references to negative emissions technologies in the Paris text. There were no references to solar geoengineering. It depends on whether or not you regard negative emissions as being geoengineering or not, whether you would regard the statement that you formally made as correct. That's a semantic point. But one important to clarify. The question I was going to ask is, I did some geoengineering yesterday because I bought 4 gallons of petrol from a petrol station and burned it in my car engine. And there were no ethics committees, there were no environmental protesters tried to stop me. No one seemed too bothered about the fact that I was changing the climate on a semi-permanent basis, certainly beyond that of a human lifetime. So why are we jumping through hoops about technologies which are simply trying to reduce the damage that society has already consented to do by running an economic system on fossil fuels? You know, we're not talking about reducing the temperature just for our general convenience here. We're talking about reducing a damage that we are in the process of producing on an ongoing basis, right? So it seems to me bizarre that we are putting such high ethical and sociological barriers of discussion in front of deploying a technology which should be absolutely common sense unless we agree to immediately and completely stop using all fossil fuels. And even if we were to do that, we still have the matter of all the fossil fuels that we'd previously consenting to releasing. So this seems to be a nonsensically abstruse discussion, and we should just simply get on with it.
Just will you do it?
Well, as you know, Andrew, I disagree with almost all of that. I mean, and I think you know the distinction that is conventionally applied to geoengineering. Its definition is about the intentional manipulation of the climate, and for good or ill, one can argue that the aim of you driving to the shop in your car was not to intentionally manipulate the climate. I'm guessing that it wasn't.
I have a much more Machiavellian attitude towards this.
But you know what? So that's where the discussion of responsibility starts from. Is should, just because bad things have happened in the past and continue that are intentional. Now there's an interesting. Sorry.
I find it unethical what he does, and most people do.
Yeah.
I'm sorry, not most. A lot of people do.
So in terms of the way that becomes complicated, and I think that's a really interesting space, is that, so if you regard yourself as in effect engaged in an experiment with negative consequences, which it sounds like you're doing, does that experiment become an intentional act once you know its consequences? Which would be one of the starting points for some climate scientists who, for example, would say that ever since we've known about climate change, we are therefore intentionally changing the climate because we know that what we're doing here. I still think that ethically there is no basis for justifying geoengineering just for the hell of it, right? You need to think carefully about whether it's the right thing to do. And as I've said, we can't do it, so we need to think carefully about how we should go about finding out about it, how we should go about experimenting with it. But the ethics are certainly more complicated than the question of, well, we are already polluting, so let's just try and pollute in a more organised way.
If you flip it around, you can look at the restriction on bunker fuel sulfur. So at the moment, bunker fuel sulfur is being restricted to nominally to protect human health, but the effect of that is that it's shielding effect over the open ocean by triggering clouds and by directly causing particulates. It's being removed by those bunker fuel restrictions, right? So we're actually deliberately, again, doing a geoengineering activity which makes the problem worse. So we've got this aerosol shield which comes from ship bunker fuel. We've passed some legislation which demands that mariners no longer burn high sulfur bunker fuel. Yeah. That is going to make the climate dramatically warmer.
Your description of that as a deliberate geoengineering though would not be a universally shared one, because most people would say that. So even if there was
still going to have that effect,
right?
Yet we still do.
Okay.
So is that not entirely willful?
Well, it could still be justified as a side effect.
Perhaps I could follow up these questions by saying that I'm hearing a lot of carefulness and thoughtfulness, and not hearing much urgency in what's being discussed. You know, there is some scenarios. It's hard to know, but there are some scenarios in which we will have the situation that Evan referred to, which is the positive feedback accelerating climate change when the methane that was frozen millennia ago, that's buried deep in the Siberian tundra, might start to be evaporated because of slight increases in the temperature, and that will make things tip. So shouldn't we be much more aggressive in analysing this, not just thoughtfully and academically, but with more of a passion to say, my goodness, we're short of options. We shouldn't be congratulating ourselves as what's happened in Paris, because that's only the bare minimum as to what was acceptable. We need a whole lot more tools. We should be having dozens more research groups analysing all these 20 questions and coming up with possible answers to each of these 20 questions. So why am I not hearing that in what's being proposed?
You're not hearing it from me. You would hear it from some people. I mean, one of the things that I'm interested in looking at science and technology is this sense of urgency that often occurs around science and technology, which are about, well, surely if science and technology equal progress, then surely the quicker progress comes, the better. And that speed, that discourse of speed had got us into trouble in the past. And one of the things I'm interested in is whether one can come up with more responsible ways to proceed, so that it isn't just bad techno-fix to bad techno-fix to bad techno-fix to lessons learnt in hindsight, rather than anticipating and proceeding carefully. So that is something that I'm actively trying to resist. There are some people who are saying, no, we need a Manhattan project for geoengineering. We need to get these options on the table as soon as possible. I think they're wrong.
Why don't we need a Manhattan project?
Why don't we?
Yeah.
Because I think there are better things to spend our money on.
Do you want to come in here?
The question of designing experiments, is it possible to design reasonably large-scale experiments, but which are cordoned off from the rest of the ecosystem? And it seems to me that this is a much better field for seeding the oceans, because you can pick a sea that is quite landlocked the Black Sea or whatever, the sea of Azov, and then start from
Yeah.
there, as opposed to playing with the atmosphere.
Yeah. So this is something that I'm particularly interested in, that I didn't have time to get into, which is the nature of experimentation when there is no laboratory. And when your laboratory has no doors, and it's... So one of the questions that has been discussed within the geoengineering research communities, would you, even if you had a technology that worked at a planetary scale, would you be able to test it or not? Which is a very interesting technological question, that if you're trying to intervene in a global ecosystem, would you be able to tell that you're having the desired effect in which you are deliberately using your world as a laboratory, given that there is no trial world? Now, subscale, so before you get to the planetary scale, the interesting question is, well, what might experiments look like to get to that point? One of the concerns here is that this is the open ocean, where, yes, you can't seal around that particular laboratory, but also it's an ungoverned space, so it's not clear who's responsible for particular things that happen there. And so all of those questions about experimental ethics that scientists might ask themselves in the comfort of their own laboratory, or for which, if you take something like a genetically modified crop, you have to apply for a license to then release that genetically modified crop into the open environment and do it at a field scale, and then do it at a farm scale, and then all the rest of it. With geoengineering, we haven't begun to think through how that might run, what experiments might look like. You know, the spice experiment wouldn't really have affected anybody because it wasn't designed to have an effect on the environment. The interesting question will be when people are trying to actually intervene in the environment in order to test effects, how we think about the ethics of doing that.
I just wanted to say, if I understand the question correctly, you're asking if this experiment is better than actually some of the could be better designed because things appear to be under control than something that's 20 kilometers above the Earth. But even though this picture looks quite nice on the surface, it will have a lot of unintended consequences which people are not yet able to measure and quantify. When you're dumping some iron into the sea, it effectively leads not only to the growth of algae but also to the acidification of the ocean. So that means that all the ecosystem will be affected, all the fish feeding on the algae and others. We don't know how it's going to affect that. So this is quite a dangerous experiment. Yeah. This is a very dangerous experiment because side effects. We don't know.
Which experiment would you say want to put money into?
Good question. But not this one for sure.
Not this one. So where would you put your money? You said you wouldn't spend it on the Manhattan Project to make geoengineering work. So what would you spend money on to ensure that we didn't have the risks of climate disaster?
Well, I think there are all, if I were in charge of the research budget, I think if you wanted it to do something of a sort of Manhattan Project scale, you would invest it in green energy.
Well, that's exactly what's going on.
Well,
it's called the Apollo Project,
and that was a really interesting move, that initiative, and actually got quite close to what a number of social scientists have been saying for a long time.
All the money has to go into research of clean energy system, which is cheaper than fossil fuel, unabated fossil fuel energy. The capitalist industry would then take it over.
So let's just talk briefly, for those who may not know, what this Apollo project is. It was announced here in London, I think, in July,
about 6 months ago,
with various people.
It was recommended by a group of very senior, very male, classically,
Sir Martin Rees,
all of those, lots of lords and sirs,
David King,
called for this, but
Sir John Brown,
and
it wasn't geoengineering. It basically said we need more money into solar. Some kind of solar.
Any energy system you can produce that produces abundant quantities of clean energy that you can feed across the world.
Yeah.
And it doesn't matter whether it's wind, solar. Solar, I think, is the top one at the moment.
Well, there's solar, but there's also battery storage mechanisms
Battery
and
storage,
also
all
a
that
better
process.
smart grid.
Yeah.
But the question of whether this breakthrough initiative that was launched in Paris a couple of weeks ago, meets that requirement, I don't
Well, I
know.
think Nicholas Stern was whooping for joy with this article, so I think he's got some money from quite a commitment from countries to put in billions of dollars to get this going.
So does anybody disagree with that? Does anybody think it'd be better for us to take a fair chunk of that green energy project money and put it instead into geoengineering? Right. Andrew, do you want to...
Yeah, why would I put more money and put in geoengineering? It's very simple. Two reasons. The first one is that there's already a huge momentum of research, mainly commercial now, going on into green energy. I've written extensively about the technology, so I've got a reasonable understanding of it. My background's in engineering, so I don't think that that's a problem that's not being solved. And secondly, it's one of leverage, that if you want to make a big difference for a small amount of money, then you do it in the technology which is powerful and under research, not the one that's big and well researched. So I think that geoengineering research is absolutely where I put my efforts in, and I'm living the dream because I'm publishing my own research on geoengineering, and I've got several papers and comments and stuff like that out. So I'm not doing this to make an academic point. I genuinely believe what I'm saying, and I'm pushing this stuff because I think it's the way forward to at least understand this technology. And obviously, earlier I was trying to game Jack a little bit, but as he'll probably appreciate. But so I do absolutely believe that research in geoengineering is the right thing to do.
And which of these different approaches that were mentioned, which of them do you think deserve the lion's share of that research?
Mainly, I'd say stratospheric aerosols, because that's the thing that is most likely to work most quickly, most reliably. I think that if marine cloud brightening could be made to work, which is certainly uncertain in my view, then I think that would be a technology with great potential, but that would be certainly I'd major in sulfur aerosols and minor in marine cloud brightening. Most of the rest is frankly nonsense as far as I can tell. Most of the negative emissions technologies they just don't scale to the extent that you'd need them to scale. The one that I think that has a real future from negative emissions technology is olivine, because all you need to do is get some rocks, crush them a bit, throw them into the sea, and the wave action will do the rest of it for you. There's no huge energy penalty, and there's no complicated equipment needed to do olivine negative emissions, which makes it pretty unique compared to other negative emissions technologies which are much more either technologically complicated or just limited in their the extent to which they can manipulate the carbon cycle.
Anybody else want to come in here? See various hands half raised.
I couldn't hear the technology of throwing rocks in the sea. You called that
Olivine is a special type of rock. It's a silicate mineral, and when it weathers, it reacts with carbon from the air. It's a natural process, it goes on all the time, and it's how the climate controls itself in the long run. It's why in the long run we don't find that the Earth either boils the oceans or freezes them, because we have that balance between silicate, the carbon dioxide coming out of volcanoes and being removed by silicate rock weathering. So all we need to do is speed up a bit. Olivine is an example of a very highly reactive rock. You mine it. Often it's mined anyway because it overlies deposits that you might need. So if you want to mine some gold and it happens to be underneath some olivine, you have to remove the olivine to get to the gold. So all you do is crush that up, lay it out on the beach, and the wave action just pounds that into dust over a period of many decades. And as it does so, it sucks the carbon out of the air. Now, if you think about a gigaton of carbon, is a hell of a lot of colloid we think that has a big financial value. A gigaton of rock, that's just a big hill. That's not much, right? So if you can grind up a hill to put a motorway through it, you can move rock on the kind of scale we need to suck that amount of carbon out of the atmosphere. It's cheap and it's easy.
So without personalising it too much, would you, if you were providing funds, if you were allocating funds, would you give some funds to the kind of projects you've heard from Andrew and from Evan, or would you put it all into green energy?
As I said at the start, I'm a Democrat, which suggests that I don't do rash things like moving large quantities of taxpayers' money around on a whim. So I don't you know, I mean, I don't know. Strategically, you know, the way that decision making happens about scientific funding, as you know, is that democratically we agree sort of broad areas where funding goes. I see a big gap in terms of strategic government funding for energy. You know, so I've looked at the figures for energy R&D over the last 50 years. These sorts of projects would all have their advocates, they would all have their critics, and would normally be decided at a more administrative level. I think it's an interesting question to ask whether they could be democratized too. You know, how would you make those sorts of decisions? So I don't know.
Question up there?
Yeah. Yeah, sorry. If climate change hasn't been the big push for geoengineering, what do you actually see would be the big push or tipping point for geoengineering on the kind of scale that you're trying to put over? Because, you know, climate change and all the doom and gloom about how it's actually going to kill us in about 50 or 60 years hasn't really been the momentum that you'd figure on a global scale to actually make these kind of large-scale solutions possible. I wonder what you consider to be the final tipping point that would actually make geoengineering possible with the financial and political backing.
So when you say possible, let me just be clear, you're saying for companies to get involved and to take it?
Well, obviously these are all at the conceptual level at this point in time, is to actually realise one of these potential large-scale geoengineering solutions.
So what would it take to make it happen?
Yeah, if climate change hasn't been such a big thing in terms of, well, we're heating up the planet, everything's going to melt and we're all going to die, then that hasn't actually put the impetus to actually make one of these geoengineering solutions come alive. What will? Well, anything...
Well, as I hope was clear from my talk, I'm not suggesting that it's inevitable that one of these things will come alive. You know, it may well be that we just move on, that we say, as we did with Star Wars, well, that was a bad idea, let's get on with our lives, right? We should keep open that possibility. I'm not saying that's the likeliest thing to happen, but you know, there is the possibility that we just move on.
It's just my concern that no matter how good the idea is and how it would actually be a solution, would there be any political impetus or cultural impetus actually?
So I think there is a question about where the capitalist driver comes from, and I think that's a hard thing to see. You know, it's hard to see how people make money from solar radiation management.
Yeah, with respect,
but it's not.
Just literally just published in the last 2 weeks on this very question, right? Because of the drawdown of carbon from solar radiation management, it's potentially possible that you can get voluntary carbon offsets, or what we might know as carbon credits, from doing solar radiation management geoengineering. And particularly with the marine cloud brightening, it can potentially be done at a very small scale. So in theory, there could be a capitalist driver, and that was the purpose of the paper that published on it. So while society at large or the government might not decide to do that, it's theoretically possible that you could just go and buy the equipment today to do marine cloud brightening and say, I am setting up a carbon credit shop, and anyone who pays me, I will run my machine for a little bit of time and I'll give them a carbon offset.
And possibly if the carbon tax system or carbon offsets was developed in the way that many people wish it were, with more biting with a higher price, then it would make these capitalist wheels run more vigorously than at present.
It would take a lot of complicated steps, and I don't see those steps, obviously. But you know, what we know is that these things are all uncertain. Let's just hold on to that uncertainty.
Time for one or two more questions. John?
Yeah, just if we assumed a political consensus in favour of geoengineering on a global basis, it would take how many years to have an impact?
Well, I mean, so some people have suggested that if the funds were available and if there was the political will that one could get this up and running within a matter of decades. Now, I think, again, that in order to construct that scenario, that involves ignoring all sorts of complexities that I think we would understand would be hugely important about the cost of doing this, about what it would take. So presuming a consensus is already a logical leap that I would be unwilling to make. But you know, so if you look at David Keith's statement saying it would be cheap and technically easy, right? This is the common rhetoric of geoengineering, that this is cheap and relatively easy relatively doing anything else about climate change. And again, I think that misunderstands technological complexity and quite what a technology of this scale and of this, you know, it's uniquely novel, and so any scenario that is constructed is going to be of far too short a time scale and of far too low a price, because it overlooks exactly those considerations.
So maybe an argument for starting it sooner rather than later.
Well, if you think that it's a good idea, then yeah. But I, again, would think that that was wrong.
Matthew?
So much of the geoengineering talk, and a good part of today's talk, is focused on one particular pollutant, which is CO2, which is just one of the many pollutants that we produce as humans or that exist in nature that we have to combat. If just talking about just CO2 is this complex, how do we ever cope with the numerous other pollutants? So for instance, the acidification of the seas, the topsoil issues we deal with, the water quality issues, and all the other pollutants that go into the atmosphere. Just one pollutant.
The methane from cows, for example.
Another example, but then all the other things that go in that, but don't necessarily cause global warming, but cause this smog that also harms people in our environments. So this is one particularly pernicious pollutant, but there are maybe an unlimited number of other ones that would have to inevitably be considered. And if we could barely get our heads around this one, what hope do we think we have for actually having any sort of comprehensive solution to what we do as humans?
Well, there is no solution, and I think part of this is part of the trouble here is presuming that this is a problem, that this is one problem that can be solved, right? It can't be solved. Problems don't get solved in that way because they're not crossword puzzles. So I think you're absolutely right to say we're even looking at just one thing. We're simplifying it down to this ridiculous degree, recognizing the complexity of ecosystems, the complexity of societies. I would say, as a social scientist, any scenario that overlooks the complexity of people and their disagreements is already flawed, and there would be more besides. And I think, again, bearing in mind all of those complexities and the uncertainties that come with them tells you quite how far we are away from some of the simplified scenarios that come out of geoengineering research.
Well, Evan?
The geoengineering would only be necessary in an emergency, and this is absolutely clear. It's not an alternative to mitigation. I mean, we must work flat out at mitigation without doubt. And I think the onset of the Apollo project, so-called, I think is an interesting start. But if things started going really wrong, we went through a tipping point. The Greenland ice cap started melting big time. Let's pretend the Antarctic started melting big time. You would go into overdrive to try and solve that. You couldn't solve it by mitigation quick enough. Do you think about geoengineering? It's pretty fast. So I think you need to do research and have it on the shelf, ready to use. And I think the Americans and the Russians already experimented with this anyway. I don't think they can hang about for worry about what Joe Public.
When you say you think,
I'm pretty sure
you guess.
I guess I'm reasonably certain they are doing it. Of course they are.
You're not visiting, you're not taking part in any meetings?
No. Not at all. But I wouldn't be at all surprised they're not researching this. The military aren't trialing this stuff.
On the nature of
and I think that's the right thing to do. I mean, just in case.
On the nature of emergencies, let me just remind everybody that emergencies are never just present themselves, right? Emergencies are declared.
Yeah.
Some people have already declared there's a climate emergency. So that will be another area where people disagree. It will be another area in which it will be in some people's interest to say there is an emergency and others to say, no, we can keep on doing certain sorts of things. And so don't presume that there will be one moment at which you say, right, now that's happened, so let's do this. Yeah. Right? That's a technocratic solution not
But
a
ice melting could be very fast, and that's the big worry. That could be exponentially fast. We don't understand ice melting. That's a big problem. If that started going big time, and I think that could kick in over a period of 5 years, where you saw sea level rises, are going to be a metre, etc., in a short period of time, you would have to think twice. That's all. I mean,
let's take a final round of comments from the floor, and then we'll come back to you for any kind of takeaway. So, yes.
Speaking about emergencies, there are already I have an emergency in China, and I don't know if many people here have been to China, and there's quite heavy smoke in Beijing and Hong Kong, and it's quite hard to breathe. So what they have came up with, because in China they have like 20 cities with population more than 10 million, they have built these bubbles, which are huge, like 2 kilometers in diameter, where people go shopping. There are tennis courts, there are parks, there are little mini lakes, and people spend their weekends, obviously those rich ones who can afford it, where you have clean air, and they sort of rejuvenate their lungs over the weekend and then go back to their towns. But my question is actually slightly different, because there are so many smart people around here. So this particular situation we currently have in the Antarctic, where we have this iceberg, huge. Yeah, if you think about this, is the Antarctic is in here, and this iceberg chopped off of the main continent, and it was moving around for years, and suddenly it started drifting towards Chile, and it's huge. It's 32 kilometers, and obviously it's going to be affecting the shipping line, shipping routes. Do you think there could be a geoengineering solution to that?
Not as far as I know.
Nuclear bolt.
Could one possibly tow it to Saudi Arabia? They could use the water with ship.
So, like I said, I'm going to wind up soon, because I do want to give people a chance to speak. So, Rupesh?
Well, I remember, like, for the Beijing Olympics a few years ago, China was accused of cloud seeding to avoid it raining on the stadiums on the days of the events. So I think, the sort of rules that we restrict ourselves by may not be being adhered to by other sort of political systems around the world. So it may be a case, and I kind of think of like the Google methodology of do it and then deal with the sort of like the suing and people complaining about it afterwards, because once it's done, and you're moving in the right direction rather than waiting for sort of like giving everyone saying it's okay, do it, because by then it might be too late, and it may need some kind of emergency circumstances where sort of democratic sort of rules and procedures are superseded by basic need of survival.
So you prefer to ask for forgiveness rather than permission, even if you need a heck of a lot of forgiveness because unintentionally you've said.
Well, China might be doing it already.
Right, Andrea.
Two very good points. First, I think it's quite dangerous to introduce things or to have things just for emergencies, because generally the human nature is that you introduce something as an emergency procedure and then it becomes permanent. Just look at the terror laws, things like that. And the other thing is, would you say that because some of these technologies, they're quite, to me, they look fundamentally different. One is sort of carbon capture, as I said, in a certain spectrum, reducing the cause of the problem is fundamentally different from this aerosol thing, which is not reducing the problem, and but it's trying to fix it, but without reducing it.
So you would vote for carbon capture rather than the aerosols?
Yes, but that carbon capture, however, does something like that.
Perhaps if there's a carbon tax put at a suitable price, then carbon capture will be suddenly financially viable. John?
Yeah, just as an interesting comment on China, if China achieves its goals to reduce the smog and the pollution, there'll be a consequence, a geoengineering consequence, where there'll be less haze, so China will get hotter, and there'll be less reflection from the haze of pollution. So in a sense, they're doing some negative of geoengineering.
Yes. Question here as well?
Well, just a couple of points of reflection. I'm a jaded Democrat, I think. You know, can you really argue what goes on in the States at the moment is, you know, democracy in a good sense. In the real world, a lot of big investments being done by Gates, Wellcome Trust, you know, in medicine and human health. And I think it's really quite likely that where the energy comes from this, sorry, wrong word, where the finance comes from this would not necessarily be democratically funded, particularly. Then you have to ask the question, where do you get the authority to proceed? And I wonder how much thinking has been done in comparing other big issues like human embryology and tissue, you know, end-of-life care, big and right to die, big cultural changes that are being driven through media, through some stories, and we're just saying in the end, okay, we might make some bum decisions, but actually, given the scale of the social need that's been you know, revealed to us, we've got to take some risks.
So I'll give you the impossible task of summing up any comments to these rich set of questions.
In terms of what these things look like, I think that's a very interesting way. So even without knowing what these technologies will become, and one thing that we know is that the technologies, if they ever exist, won't look like they're currently imagined, because no technology has ever looked like it was imagined on a drawing board in the absence of any investigation. The SRM versus CDR distinction is one way that you can think about different types of challenges. You can say there are particular issues presented with one that might not be presented with another, but equally you wouldn't just want to say all CDR are the same. You know, is ocean fertilization the same as growing trees? Well, probably not. You know, so whichever way you cut it up, you're making choices. Would be my argument. Now, on the question of democracy, so some scientists, like Jim Lovelock, for example, have said that climate change is too big a problem for democracy to solve, implying that it justifies, in effect, a form of emergency approach, some form of martial law. And I think that's profoundly depressing, right? I think any response that says democracy is the problem, I think the solution has to be to come up with a better democratic solution, more democracy, not less. So I'm unwilling to concede that democracy might be the problem here, because I think that's too big a thing to give up. And there I would say that something like embryology gives you a very good test case. The British approach to the regulation of embryology and fertility research and clinical applications was done more democratically than with many emerging technologies. It was done in an open way with the engagement of scientists, ethicists, Parliament, and some public dialogue as well. And I think that provides you a very interesting way forward. That wasn't the case, for example, with genetically modified crops, which ended up controversially, nor was it the case in the States, where the same areas got into trouble because of a failure to understand the politics. You know, I will not concede that the answer, therefore, is to circumvent politics. Right? I think what we need to do is find ways that we can make our technology work with democracy and make democratic technologies, not ways that we can circumvent democracy in order to deal with emergencies that might or might not be agreed upon.
Well, that I think is a very good note to leave it. So there are more London Futurist events in the future, of course, not until the new year. I think it's the second Saturday in January. We are having an event on cybersecurity and cybercrime on Saturday afternoon in Birkbeck, possibly the 9th of January, if my memory is right. And then there are other events which are in the process of being planned. If you want to continue the discussion tonight, a small number of us will probably make our way briefly to Marlborough Arms Pub on Torrington Place for a short discussion on all aspects of the future. But for now, let's warmly thank Dr. Jack Stilgoe for this fascinating lecture.